Hey there. Thanks so much for having me and letting me talk about some of my favorite open source projects right now. Andy already showed you the lightweight open source VR engine LÖVR, and I'd like to dive into some of my favorite parts of it. After that, I'd like to talk to you about the open, collaborative, and spatial app platform Alloverse that me and some other very passionate people are building on top of LÖVR. First, quickly about myself. I'm Nevin Bengtsson. I like to pretentiously call myself a code poet. I grew up in Macs, and this lent me an inclination towards UX, and I spent a lot of time thinking about human-computer interaction in general. I studied game programming at uni, but got hired at Spotify immediately after to build their iOS apps. I didn't really do any game dev. I went on to start the UX research platform Look Back after that, which taught me just way too much about the iOS media pipeline. Once that worked pretty well, after about 7 years, I decided to do something completely crazy and just combine all of my hobbies into this one mega project, which became the startup and open source project Alloverse. But before we dive into that, let's talk about LÖVR. So as Andy already told you, LÖVR is a game engine specifically for writing VR games. So LÖVR's main creator and maintainer is Bjorn Bytes, and other contributions are from a bunch of people, including Andy McClure, myself, B. Campbell, Jay Miskovich, and others. And the two things I like the most about LÖVR is one, the really nice, inclusive, and helpful community, and the other is the engine's really beautiful simplicity. So LÖVR is heavily inspired by Love, which is a 2D game engine for making games in Lua. And it is an approachable and simple engine. And when I say simple, I don't mean it in a condescending way, but that both of these engines let you make games without delving into built-in complexity. So, Unity might be easy for a beginner if you're following a tutorial because it does so much for you. But once you want to do something on your own, it's kind of hard to find out how to do it, where to find it, how to extend it if you don't like the defaults, and so on. So I think a great visualization of this is the classic Hello World, because in Love, it's just these three lines, love graphics print, and you get Hello World in there, and it sets up your window, your OpenGL canvas, renders to it every frame, and it's just three lines, and that's your entire project. I think that's really cool. LÖVR takes this to the next level because coding for VR is actually pretty difficult, even if you have something like Unity or Unreal. There's a bunch of different headsets, and they all have different APIs. I remember you're rendering from two different from two different perspectives. Like you two eyes, you need two different perspectives. The headset itself is tracked and moves around, and that moves your in-world camera, and you need to keep track of that. And just a bunch of different stuff. So the same example in LÖVR is also just three lines. And what I think is so cool about this is with these three lines, you got some text that you can actually walk around and immersively experience that. I mean, it's just text here, but like whatever you build, like it immediately becomes immersive, which is so cool. It's quite a magical feeling. So actually, there's a third thing I really like about LÖVR as well, and that's its internals, which I've been messing about with quite a bit. You write your games in Lua, but LÖVR itself is written in pure C. And before I dig into that and show you some of the internals, I'd like to give you a quick tour of the API, just so you get your bearings. I don't know how much Andy already showed you, so I'll just do a quick once over. I managed to cram the entire API into basically one slide. No, it's not the entire API, but it gives you all the basics of the API into one slide. These are some of the most important ones. These are basically callbacks for your app run lifecycle and runtime. So you set up your app, you every frame you update your game logic, and every frame you draw it, and so on. And then you got some external events here. So if you implement some of these callbacks and use some of these modules, then you have your game. And you got all your basics like audio and graphics and physics and math. There's going to be quite a bit of math if you're doing anything slightly advanced in VR, unfortunately. Um, but I especially like the headset module. All of these are really easy to use and encapsulate whatever you want to do. But the cool thing in VR is, of course, being able to think about things spatially and tracking a human body. So, like, you can get the pose of the headset itself and your controllers, or even your hands if you're hand tracking on the Quest. And you can get more information about all of these devices and track all that in real time. All that is really great. So you have the callbacks and you have the modules, and that's mostly everything you need to know. There's a really, really great documentation website, lover.org/docs, and that just goes through all of these with very in-depth documentation. Okay, so that gives you a gist of what working with LÖVR could be like, hopefully, especially combined with what Andy already showed you. So dipping into the internals. So it's easy to write bad C code bases and to overcomplicate things with object orientation and macros and function pointers and indirection. And I mean, I've done quite a bit of that myself. So I think it's a joy to work in such a well-organized C code base. So first off, the file system is really clean. It's the top level is like 2 folders and a CMake file and a README basically. And inside so first the deps and the lib folder, they have external dependencies, either as submodules, so just in lib they're just copy pasted in header only libraries and stuff like that. But if we dig into the other folders, especially the API one, this is the folder that contains the Lua API. And the API folder and the main.c are, I think, the only files that touch Lua whatsoever. So basically, the rest of the engine, you could use it as a C engine, even though Bjorn doesn't promise anything about the stability of that API. Everything is very well modularized, so Lua doesn't get into all the different stuff. And the Lua wrappers are really nicely written as well. Like, you got your all the files are L underscore and then the module and then the class, so it's all very well organized that way. The Lua wrappers are very thin and just dig into the C API, and then you just register your modules as you usually do in Lua. So that's nice. Core over here, I'm not going to go into it. It's basically OS wrappers, not a lot of it. Lib I talked about, resources, that's like stuff like Android manifests and stuff. And then modules then, that's where the fun stuff happens, because again, this is basically an entire C game engine. And it's mostly not documented, but I don't even mind because it's super succinct and easy to read and does what you expect it to do. And each module is very, very well separated. They barely include each other at all. So that's super nice. If you're digging into the internals, or if you're writing something really hairy, and you have the need to debug C and not just Lua, I thought I'd show you how I work with that. So if you have a problem with a specific Lua API, you can usually just go to source API, the name of the module and the name of the class, and you can find the source right there. So it's really easy to find where the Lua code is wrapped into C. And then those just call into modules. So you can go from there, just go to definition from there, and you'll find the actual implementation of the thing you're working with. And then you can tinker about and load it into GDB or whatever and try it out. But once you've tinkered, you're probably going to crash a bit. I mean, it's C after all. So I thought I'd share one trick I use a lot, which is I define this function called Alloprintstacks, and I don't use it in the code base. It's just for use from GDB. And so when you crash, you do BT to get your stack trace. You find one frame in your stack trace that takes the global or the current Lua state, which is always called L. And then you can do P void Alloprintstacks L. That should say L, not T. Sometimes it's actually called T, but mostly L. And when you do this, it will print the Lua stack. So that gives you the C stack from BT and the Lua stack from this hack right here. And you can correlate them, and you can most of the time figure out exactly what's happening. So that's nice. I think even if you're in Unity, it's usually pretty hard if you want to go between like C# and C. So it's actually, it's a hack, but it's actually pretty unusual to be able to get stacks from both environments at the same time. Cool. So that's some of the internals. And I'd also like to talk about the things I'm looking forward to in the future of LÖVR. Me, Bjorn, and Andy have been working on spatializers. So they have added APIs on top of Steam Audio, also known as Phonon, and Oculus Audio. So those are in main right now, and they're currently being worked on more to add more features. But it's really cool that they've managed to add a common API on top of these two kind of different audio APIs, and they give you really, really cool audio features like occlusion based on actual geometry. So you can send geometry into the sound engine, and it'll bounce the audio around and give you pretty correct occlusion and reverb and dampening and all kinds of stuff. Or you can set room effects or filters or whatever. There's a lot of features in there, and it's really cool. Another thing Bjorn has been working on for months is Vulkan support. So LÖVR is currently built on top of OpenGL, which is OpenGL. It's not a lot of fun. Lots of global state and stuff. I'm not really a graphics programmer, but the two things I'm really looking forward to is basically having no global state. So it's an API. The LÖVR API is now a lot more explicit. I mean, Vulkan is extremely explicit. It's a crazy API. But Bjorn has managed to keep the Lua API pretty easy to use if you don't want to dig in. But if you want to dig in, you get access to most of the stuff you need. And no globals. And the other thing is being able to use the GPU from background threads. So like loading models and stuff isn't really possible to do in the background with OpenGL, I think. But with Vulkan, you can access the GPU from background threads and do a lot of interesting things. I'm not going to talk about the deployment thing, I think. But I'd like to mention that there's a new plugin system, which is both source or binary. So if you put source code in the plugins folder, C source code, it'll be built together with LÖVR and become part of the LÖVR API. So that way you can add some more functionality in a way that's uniform with how all the other modules are built. This also works binary-wise. If you build something with a Lua API, you can just put it next to the LÖVR exe file on whatever platform, and it'll be loaded in and made available. So whether you like source or binary, either work great. And there are plugins for CJSON, ENet, and you have working on something for MIDI, and there are some new ones coming. So that's really nice. So there are a ton of more aspects of VR programming, of course. Whoops. I don't have time to talk about all of that now, but if you want to come talk to us about it, ask questions, feedback, whatever, come hang out in our Slack. Yeah, so that's some about LÖVR. And now I'd like to talk about the shenanigans we at Alloverse have been up to on top of the same engine. So you've already seen Andy talking about building games in LÖVR, so now I'll talk about building other crazy stuff on LÖVR. 1 second, sorry. Okay, so, you know, I love playing and writing games, so that aspect of LÖVR is great. However, my current passion slash obsession is to be able to do productive work in VR. Like actually sharing a surreal crystal palace on a hauntingly beautiful alien planet with my colleagues, and then using this extra third dimension that we don't usually get with a flat screen to build user interfaces hitherto unknown to mankind, and ushering in a new era of intuitive, amazingly powerful human computer interaction patterns. That's my dream. So I quit my successful and lucrative startup to once again live off my savings and take on a ludicrously overambitious project to basically build a three-dimensional collaborative operating system. So that's silly, but so much fun. So you could say Alloverse is basically a set of open source, distributed, federated network protocols and standards, the implementation of them in C. There's a UI toolkit, sort of reminiscent of building an iOS or web app, but actually a real-time server-side API. And we have it both for Lua and C#. And of course, we have the user-facing software, which is written as a LÖVR game slash app. So I don't know if any of that was intelligible to someone who hasn't already been deep in building metaverse software for years. So let's just check it out to make it less abstract. So demo gods, please be kind. And yeah, so here's what Alloverse's menu looks like on the desktop. Of course, it runs in VR as well, but that's harder to demo. So I'm just going to run the desktop emulator right here. So let's connect to a place. So a place is, yes. So a place is a server where you connect and other people connect and you hang out and you can talk and do work together. And this is the initial sort of co-working place we've created. A nice little house. We're still working on the environment and making it extensible so you can make whatever environment you want. But this is a start. So in here, I made this UI. I'm waiting on our designer to make it pretty. So sorry about the programmer's art. I'm going to grab this clock and put it here. And maybe this drawing board and put it over here. And so these two things are actual Unix processes running somewhere on the internet. So you got this place here that we're connected to. That's one server. But then these apps are actually also running somewhere else on the internet. And they're all, everything is connected to this one place, and other people could be in here using these apps together with me. And then there are other places with other apps and other uses in there as well. So I think that's really cool. So one thing I was gonna do is build one of these apps in real time here with you. Let's see how that works out. So there is a one-liner that, oh, no, let's not do it in here. Let's see, to do. That lets you start. There's a one-liner that you type to create a new project, and it's going to download all the things you need. And there we go. And there's a getting started guide on our website that guides you through all of this stuff if you want to do it yourself. But basically, all the dependencies and everything is in here. So this is completely self-contained. And I can do allo assist, run, and then the URL to the place that we're connected to. I'm going to move these out of the way. And then run the app. And hey presto, here it is. This is the app running in this terminal. And if I press, can I get these on screen at the same time? If I press this button, It prints hello! Hooray! And if I edit this code, can I get that in frame as well? Yeah. And let's see, we have a button in here. It's just 2 decimeters wide. Let's make it 4. So this is code written for the AlloUI framework that I talked about, and this is the basic template you get. So it's views and subviews and callbacks, and tries to be a nice, easy to use UI framework. And I'm gonna save that, and you remember what it looked like, right? But now the button is wider, and let's make it tall as well. Like that, and then kill, run. Whoa, super tall button, wow. So that's AlloUI and building Allo apps. Just a quick demo. And let's get back to the slides. So I'm able to do this entire presentation within my slot. Okay, back to the notes. Cool, that's the demo. That's nice. Let's talk about the architecture of this. Because from my understanding, you, as me, are a bunch of nerds, and you love knowing how things work. So let's do it. So these are some slides I usually show people to explain just the difference, because there are tons of different apps for social VR or for having meetings in VR, and they're all built around this classic, boring client-server model where you have a proprietary, maybe open source VR app here running on the headset, and then you got a server somewhere, or a cluster of servers running in the cloud, and they're proprietary whatever somewhere on the internet, and the functionality is shared between these and built into these, into the backend and into the headset app. That's not how we do it. We still have a headset app, of course, but it has basically no functionality in itself. It can only render what the place tells it is in it. And the place itself also doesn't have any logic except managing users and audio streams and stuff like that. But it doesn't have a whiteboard or people even. It just has entities and media streams basically. And all the logic is implemented as apps. So the whiteboard was a Unix process running somewhere, connecting to the place and providing the whiteboard functionality, and all the different apps, all the functionality, even the house you saw was an app, and even the skybox is provided by the app. So it's apps all the way. And just quickly, what does this look like on the wire? So it's a UDP-based protocol, as most game protocols are. And at the bottom, we've used eNet because it lets you mux in multiple channels, and you can have unreliable channels and reliable channels. And on one of these channels, we send and receive the world state as deltas, and the client's current intent. So these are just pushed at 20 hertz intervals. Yeah. So all the apps and visors or headset apps knows what the world looks like, and the place knows what the apps and visors wants to do. Interactions are what we call the RPC layer. I'll talk more about that. We transfer assets like textures and models back and forth, and then audio, video, and stream geometry are over a third channel. That's not future. We've implemented that. This is an old diagram. Sorry about that. So this is on top of eNet, which is on top of UDP. I considered using WebRTC. It provides a lot of features like all of these things basically, and tons more. And on paper, it sounds great. I've worked with WebRTC for a few years at Look Back, and I just hate it. I want to burn every line of SDP in the world. But we might end up having to use WebRTC anyway, because it's the only way to access UDP from a web browser. And it would be really nice to be able to run as a web app as well on top of a desktop app and a standalone VR app. Standalone, yeah. Yeah. So let's dig into the data that's transferred over these wires. The world description is basically a really big JSON blob of entities with components. So entities are things in the world. Components are the properties of those entities. And these are hierarchical, so it's a scene graph. And it's also declarative, so it's sort of like the HTML DOM. You have a thing that owns a thing that has attributes. And this describes the look and behavior of things. And apps basically say, hello, I would like to represent myself with these entities and these components. And the placer creates them for the app, and then the visor receives these and they see, okay, here's a box, let's render the box. And the low-level API is in C with bridges to Lua, C#, Erlang, and a bunch of other languages, and more coming. And this is all documented on our website, docs.alloverse.com. It's got like high-level documentation, low-level documentation, and protocol specifications, and all that stuff. So you can go check that out. Here's just a quick example of what that looks like. 3 entities with various components. Interactions are RPC calls, so they're basically JSON blobs that can be either request response or pub sub. And I'm gonna skip the details because you can check the website if you want to know, and I'm running out of time. And AlloUI, I showed you a demo of it. It's a familiar UI concept transferred to 3D, except it looks like a client-side API, but it's actually server-side. And we're trying to do everything server-side so that when you write an app, you don't have to sync data between multiple like client-side apps, but it's all running in one process. So it's really easy to build collaborative apps. And I think that's super important because that is usually so very hard. Not interesting. Not interesting. Okay, let's move on. I want to share some interesting tidbits of Alloverse. Some of the really fun stuff we're doing. There is no local UI. When you start this app that I showed you before, let me do it again. This black is all the UI there is, and then it starts up an actual network server locally, like inside the app, connects to it, and runs some Allo apps. So these widgets over here are actual functional networked Alloverse applications. So sometimes this avatar chooser crashes and then it just disappears from here. And you can restart it, or yeah. So I think that's really cool. All the UI is using this networked UI layer, even the local UI. And when you're connected to a place, you're actually rendering 2 worlds at the same time, the remote one and the local one. So that's cool. Another cool thing is, since the apps are like actual Unix processes running on the internet, you can do whatever you want in them. For example, Alloverse, the AlloUI library doesn't have a canvas class. You can't do 2D drawing, but you saw me drawing on it. So what it does, it imports libcairo using Luajit's FFI library, which is great. Like being able to call C directly from a high-level language like Lua is just crazy. And it creates a Cairo canvas, draws on it, sends that buffer over the network, and sets that as the texture of the app itself. We want to do it as MJPEG. That's coming up in the next few weeks, but currently there's an ugly hack to transfer that texture, but it works. And you're going to do other things like the file viewer imports a PDF library, for example. And the grand idea here is that you can build AlloUI into your fancy existing backend or even your fancy existing desktop app. And that way, really cheaply get a 3D VR compatible UI to whatever functionality you already have in whatever language you already have it. Or you can use some existing library or whatever. So that's really cool. And I mean, yeah. Okay, let's move on. Oh, I'm almost out of time. Mouse picking. I don't have time to do this. The math for positioning the hand so that it points exactly where the mouse cursor is really nice. I really enjoy doing this math. Um, Ask me about it later. Why not WebXR? Um, this is super important. WebXR builds entire environments, not apps. So if you want to like be in an environment and import multiple apps, you can do that with some hacks in WebXR, but it's not built for it. And if you want to add collaboration, it's client side. So you're going to have to do syncing of different clients. It's really hard. Why not Unity? Don't want to get locked into proprietary tech. It's for building client-side apps, and this is very server-side based. So we wouldn't be able to use a lot of a lot of the functionality. Yes, it is an unsecured protocol right now. We will be adding TLS, of course. It's just we're a small team, and we want to make it work before, yeah, enough excuses. I really want to show you this GIF before I end. On the left is what we managed to do in the first year when we worked on this as a hobby, part-time, like audio streaming, entity syncing, and VR support and all that. That was really cool. But I'm so impressed with this team has been able to do in the past year when we're actually been working on it full-time. We have a bunch of apps. You can be in there, a bunch of people. Like we think we've been 6 or 7 people in there with voice communication, using apps together, and it's just really cool. Our current focus is to get ourselves to spend more time in Alloverse. So we will actually want to work inside Alloverse for several hours a day, preferably. So we're doing screen sharing and some other nice features to be able to get that. And we're building a marketplace where we're going to get subscription pricings and hosting and publishing. So if you build an Allo app, and we really want you to build an Allo app, so we can have a large catalog of apps and functionality so that more people get use of Alloverse. And the long-term crazy vision is to become the open and free standard for XR collaboration and for building XR apps that are collaborative, because it is inevitable that Apple and Facebook are going to do their own, but they're going to be centralized walled gardens, and we don't want to be locked into that. So that's Alloverse. That's a lot of LÖVR and Alloverse for you. If you want to come talk more, go to alloverse.com/community to join our Discord. Hit me up on Twitter, email us, whatever. I just would love to hear more of your thoughts. That's 3 minutes over time, and I thank you so much for listening. Bye.